If we look at formulating systems of equations in three variables from real-world situations, we have some examples here. A child has $6.17 in change in her piggy bank. The change consists of 113 coins and a mix of pennies, nickels, and quarters. If there are 8 times as many nickels as pennies, how many of each coin does the child have? Solve using substitution. So I got another note card out. You can get another note card to make some notes about steps we can take to solve this system. So we can look at writing. So writing systems in three variables. Word problems. And I take the same steps that I've taken before on writing equations from word problems. The first thing I think about is what is being counted. So I look for things that repeat. And if we have three variables, I'm most likely looking for 3 repeats. I see that we have pennies and nickels and quarters and pennies and nickels, coins. So we're talking about these 3 different kinds of coins: pennies, nickels, and quarters. And the next thing I look at is what are the totals. And not only do I look for bigger values, but I look for keywords such as is or are. And so I see that I've got a total of $6.17. I've got 113 coins, and then I've got this R relationship here, 8 times as many nickels as pennies. So I can create 3 equations from this information, and that's the last step that I take, is how are the totals made. And so I want to make equations out of these 3 variables, and if I have 3 variables, I need 3 equations. And I want ones that I can solve by substitution that are going to be the easiest to solve. So there will be some things we can do to make our equations easier to solve with our totals that we have. So let's look at our information and first look at the pennies, the nickels, and the quarters, because the total of each of them put together is 113. And they give that to us in the problem. They also say that there are 8 times as many nickels as pennies. So that means that there are more nickels than pennies, which means the nickels are 8 times the pennies. So it almost seems reversed. And then we have this total of money, the $6.17. And this is where we think about the value of money related to a dollar. A penny, a nickel, and a quarter all make up different values in a dollar. So a penny is 1% of a dollar. A nickel is 5% of a dollar, and a quarter is $0.25, so 25% of a dollar. But we can make this easier on ourselves to solve if we can get rid of that decimal. So these are percentages, right? And so that means that, and it's also that same principle of whatever we do to one thing, we can do to everything. So let's say I want to make this like percents, like whole numbers, like integers. So if I move this decimal place over 2 times, like if we were doing scientific notation, I can move this one over 2 times, and this decimal place over 2 times, and this decimal place over 2 times. So we can rewrite our equation as 1p plus 5n plus 25q equals 617. And then our equation becomes easier to solve. And we want to solve it by substitution, which is perfect because we have this value for n that they give us here. So let's use that value for n to substitute into this equation that we're given, that we just found, and the first one. So into this first equation and to the one we just found. So we see that p plus, let's do the second equation first. So p plus 5 times 8p plus 25q is equal to 617. And then we simplify and combine like terms using PEMDAS. There's p plus 40p plus 25q equals 617. P plus, well, we combine like terms now. So we have 41p plus 25q equals 617. And that's as far as we can go with this one. But we have the other equation too. So let's use the other equation. We have p plus n plus q equals 113. But now we have n equals 8p. This 8p here is the same as n. It'll be the same as n here. So we take p plus 8p plus q equals 113. So 9p plus q equals 113. And now we have something we can multiply to eliminate and get a variable all by itself. Or we can get a variable by itself and substitute. I see that q, this q all by itself here. So I'm going to subtract 9p minus 9p. So q equals 113 minus 9p. And I can substitute that back into any equation except the first one. And you can answer here, why can't I substitute this new equation into the first equation we wrote? Write this new equation here. You can answer that question here in your notes as well. And then we can substitute it into here and solve for p. So let's do that. 41p plus 25 times 113 minus 9p equals 617. Because all of these q's are equal to each other. And now I'm going to need a calculator. So let's bring up Desmos, trusty Desmos calculator, and I'll distribute throughout this parentheses with the 25. So 25 times 113 is 28. 25 minus 25. 25 times 9, which is 225p, equals 617, and we bring down the 41p as well. Let's write that better up here. 41p plus this. And now we'll combine like terms. We don't need the calculator anymore. Maybe we will. So subtract 28, we will. So subtract 2825 minus 2825. So 617 minus 2825. And we get 41p minus 225p equals negative 2208. And then we have 41 minus 225, and that's negative 184p equals negative 2,208. And these are funny values to get for pennies, right? But then we can check ourselves by seeing that we divide by negative numbers in this last step, which means we will hopefully we should get positive number of pennies. So 2,208 divided by 184 is 12. So we have 12 pennies. We have 12 pennies, which means, and let's highlight this a different color. This is the last value we needed. Well, the first value we've really found, right? But now we can substitute it into these equations that are easy to solve for. So we see that N is 8 times 12. So the nickels are 96 nickels. There are 96 nickels. And then let's find out how many quarters there are. So we can do 12 plus 96, and 12 plus 96 is 108. So 108 plus Q equals 113. And so the quarters are 113 minus 108, so 5. Right, 5 quarters. There are 5 quarters. And so we found each of our things. Let's write our solution very clear and to the side. So our solution is 12 pennies, 96 nickels, and 5 quarters. 5 quarters. And so you can use these steps and the steps on your note card and this model, answer this question, and solve the rest of these practice problems looking for things that repeat, right? So pieces that repeat in threes and totals associated with those pieces.